All right, let's just finish up this one problem. First, let me teach you something. So let's get this text right here. We're gonna bring it over to this section. And if we haven't done this, then I guess this is the first time we're doing it, huh? We're going to merge those cells. So you can do it here with this shortcut, or you can do it in Format, Merge, Merge All. And then we're going to Format again, Text Wrapping, Wrap. And what it does, it just puts all the text in that small space. Obviously, you can see that we needed more cells, so we're going to merge more cells. There you go. And then we're going to just put a different color to distinguish this as key information. We can probably insert a one to the left there. Just make sure that it's to put some space in between this information and this information. And this is just for aesthetics. Now we're going to bring this other one over here. Select a larger space or a number of cells. Merge them. The shortcut is here for text wrapping. There you go. We didn't need that many, but that's fine. We could even increase the size of the text to 12, and that should just fix it. So with that said, that is going to help us with our next step. Go to blood pressure problem 2. Go ahead and select this text right here. These are like the questions that we need to answer. Copy it and paste it somewhere in here. Space large enough that you can answer these questions. What I discovered is that for whatever reason they have this bottom formatting in them. I don't know why. So we'll change the bottom formatting to the top, and that's going to make a difference, trust me. Now we're going to separate these questions so that we can see them clearly. And this is more for me, so that when you answer these questions, I can see them in one spot instead of having to scroll like this, because we're going to type quite a bit in just a moment. And so I don't want to be scrolling all the way over here. Therefore, we're going to click and drag and select probably about that much. Let's see how that goes. Then let's do text wrapping. Perfect. Actually, let's leave one more space in between, which means we need 3 cells in between each question. Select 9 cells, 3 by 3, merge them, wrap. Perfect. This actually doesn't really need anything else, so we'll leave it as it is. This one we'll just do 2 by 3, merge, wrap. Perfect. I think the only thing is we'll merge it just so that it looks the same color. Okay, I don't want that R to be cut off. Alright, let's merge. First unmerge. And then let's merge these 4 cells. Perfect. Yes, okay. Copy paste to get rid of that green spot. Now, for this, the corresponding answer, we'll put it over here. And let's select this space right here. Can I just get rid of, let me see, is there anything any important information? Nope. I can get rid of this cell. Delete column, or this column. There you go. I don't know why I deleted that column. I don't think it was necessary. Okay. There it is. That's what I needed. So now I can select this whole thing. Oh, by the way, that was my mouth. Please don't think it was flatulence. I didn't pass any air, please. That's gonna go down in the video. Okay. So let's merge, wrap, and put a different color so that we don't lose that space, because sometimes it's easy to lose in the background. Any color is fine. I'll just put a boring gray right here. We'll do the same thing with this. Merge, wrap, gray. Merge, wrap, gray. What? Merge, wrap, gray. Merge, wrap. This is where you speed up the video so that you can avoid all this. All right, here we go. Interpret the p-value from the t-test in relationship to the null hypothesis. By this point, you know what a p-value is, you know what a t-test is, all this stuff. Perfect. Here's our p-value. 0.016. Let me pause the video. Okay, here we go. So I put this here. You'll notice that the threshold is really 0.05. Now, let me just explain this real quick. If our p-value, you'll notice here, this is 0.01, which falls right here between 0.01 and 0.05, it means that there is some evidence. Basically, this is a standard number, 0.05. Anything below, anything greater, let's just say that, anything greater than 0.05, make it simple. Literally like 1, or the number 0.9, which we saw in another video. All these we tend to fail to reject the null hypothesis. If it's a very, very small number, then there's a very strong evidence, and we absolutely reject the null hypothesis. So let's wrap up this video. Our p-value is 0.01. Although here they seem to be different, but our error bar showed that maybe there wasn't enough evidence. Our p-value tells us, look, these bars are so close, they barely overlap. We are going to go ahead and say that our p-value, can I put this here? Okay, there you go. Our p-value shows there is evidence. So will we reject the null hypothesis? That is the big question. Will we reject our null hypothesis? Yes. Yes, we will reject our null hypothesis. I think we can say there is evidence that hair that is blow-dried has significantly less strength than hair that is not blow-dried. Now, how much? We learned that before. We don't know. We can't say with certainty, oh, it's exactly the difference between these two means. Maybe those two means are just by random chance. Maybe we just happen to pick out some hairs that were from a particular section of your hair that are weaker or stronger. So what we say here is p-value shows there is evidence. We will reject the null hypothesis. I should make this a larger font, huh? What? That didn't make it a larger font. 14, there you go. 14. Interpret the p-value from the t-test in relationship to the null hypothesis. We will reject the null hypothesis and potentially accept the alternative, which is that there is a significant difference between these two. Well, we don't really say significant. They're statistically different. Yes, there you go. Now, state whether the means are significantly... Okay, so here we go. So what does this mean? You know, because anybody could say, I'm just going to choose reject the null hypothesis, see what that goes. Well, now you need to tell me, what does that mean? What does it mean to reject the null hypothesis? Here, we're going to say, put this in 12 size, we're going to say that the two means are statistically different. You could say that there is a statistical difference between the two, whichever way you want to say it. For here, we're going to say the two means are statistically different. You don't have to put this, but remember that being good scientists, we have to say we don't know exactly how different. We just know that they're different. So don't go around saying, hey, pull my hair. It's not blow-dried. It's super strong. That doesn't work. State whether or not... Oh, and this is just from the other blood pressure problem. So here we're going to change this to state whether or not blow-dried hair is stronger than non-blow-dried hair. So what we're doing is we're just breaking down what things mean. Okay, we reject the null hypothesis. What does that mean? It means that the two means are statistically different. What does it mean that the two means are statistically different? It means that blow-dried hair is weaker than non-blow-dried hair. Change that to a 12. And then finally, we're going to support all this. So we're going to get into some detail. Yes, we reject the null hypothesis. Yes, the two means are statistically different. And maybe this goes over here. No, we leave it there. And then blow-dry hair is weaker than non-blow-dry hair. Okay, so what does it mean? Well, we are going to say, it's almost like restating this whole information. We can reject. Oh, come on. We can reject. Let me type, and we'll be back. And here we are. I'm gonna change this to a bigger font. I just needed some time to type it. Let me select more cells. So although we rejected the null hypothesis and we did state that the two types of hair are statistically different. Oh no, give me a moment. I'm gonna Zoom meeting. I need to mute. We need more evidence because the error bars do overlap slightly. So what that tells us is that there's a chance that if we were to repeat this experiment one more time, we might get different results. That's how we interpret this. And with that, we have finished this one problem. Thank you very much, and we'll see you next time.